Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast, coming to you from the massive studios here in Raleigh, North Carolina. We've been talking, we've had the opportunity a couple times in the last month or so to talk to some folks associated with the Cloud Native Computing Foundation. So we had a chance to talk to Dan, who's now running that. We had a chance to talk to the folks from the Prometheus team about what they're doing around monitoring and so forth. And, you know, a lot came out of the LinuxCon / ContainerCon days this week. And one of the big announcements was the Cloud Native Computing Foundation, in partnership with Intel, has basically made available to the public a 1,000-node cluster that is going to allow people to do some very cool, large-scale testing, do some joint collaboration with people, really provide an environment for people that want to be working on the types of technologies that the CNCF has been actively working on. So Kubernetes and a lot of things that are coming down the pipe. So today we're very, very lucky. We have Jeremy Eder from Red Hat, Performance Engineering from Red Hat, who we'll let him explain it, but worked on a very, very cool sort of initial project on this 1,000-node cluster. So Jeremy, welcome to the show.
Thanks a lot. Yep, I'm actually fresh back into the Raleigh area from LinuxCon, ContainerCon, and Cloud Native Day just yesterday. So yeah, we spent 6+ weeks, I think, working on a project on the CNCF gear, and it's been tremendously productive, I think, not only for Red Hat, but for the larger open source community. Yeah.
So before we dive into it, give us a little bit of your background, how you got, what you're doing over at Red Hat, and then how you got involved with this project and this huge cluster environment.
Right. Well, at Red Hat, I work in the larger performance and scale engineering team, and there's some 30+ folks at this point that cover performance and scalability across Red Hat's product line. My smaller team handles OpenShift and container-related things like Docker all the way down to the kernel. Okay. So, we actually have several people from different groups and collaborating in a larger kind of scalability effort for OpenShift. So while I was the author of this blog and we're talking today, this was at least a half a dozen people worked on this project.
Yeah, absolutely. And I think when people take a look at the blog, and it's, as always, it's in the show notes, folks, it is a massive undertaking. So yeah, the expectation that one person could pull it off is not realistic. So let's talk about what the project was. You did a huge write-up about it, but essentially you guys built a 1,000-node cluster to be able to do container platforms, sort of virtualized infrastructure for the cloud piece, and then run a ton of applications on top of it. Give us the highlights and some of the, kind of core architectural considerations you had to make.
Yeah. So the background is that we have, this wasn't our first foray into the scalability testing of OpenShift. We've been doing it since prior to even GA of OpenShift 3 scalability testing, and we've gone through maybe 3 or 4 iterations at a decent scale before now. And so building all of the test harnesses and scripts, et cetera, and automation to make that work was really what allowed us to get usable data out of the CNCF environment. And so we had written test plans that we had previously executed, and we just extended them for these new capabilities, new hardware capabilities in this larger environment.
And, this environment was, I assume the goals were, test, not only things like OpenShift and OpenStack, but really kind of, there's a big difference between architecting or pulling together kind of a proof of concept. You want to test a few features and thinking about, what do I do when I get to these larger scales? Like, what were some of the core things from an architecture perspective you had to kind of plan for in terms of resiliency, scale, how to automate things?
Right. Well, one of the basic things that we learned, and we've been building out OpenShift 3 environments on Amazon for decent scale for a couple of years now, and so we had some best practices built out for those. So we certainly weren't starting from scratch with this environment. Mm-hmm. We kind of already knew most of where the scalability issues were, and the major things are to ensure that you've got multiple masters, Kubernetes master in a cluster, not only for HA, but really for scalability. So a single master will limit you in scale far below what we were able to achieve here. And so we're working with a 3-node cluster of masters and a three node cluster of etcd systems, although etcd doesn't seem to be breaking a sweat very much.
For folks that aren't just digging into Kubernetes, let's kind of step back a second and talk about a little bit of the basics. Within OpenShift, Kubernetes is the kind of core scheduling orchestration technology. What's the role of the master? Why is it so important to have scalability of those masters?
The masters coordinate all of the activity between the nodes. Basically, the scheduler, the activity and command and control occurs on those master nodes. So there's a lot of communication paths between the nodes themselves and the masters, and that's where the scalability issues generally come in. Those communication paths are currently actually being optimized, and I want to say significantly. Part of the testing that we've done, and we're still poring over the data, is comparing with something called protocol buffers on or off, which is a feature that landed in Kubernetes 1.3, and we're going to have in OpenShift as well. And so we want to have an A/B comparison of how much efficiency we gained by enabling protobuf, which helps more efficiently encode those communications in a binary protocol rather than a JSON format, which we knew was particularly CPU intensive just based on looking at profiling or pprof profiles of the Go binaries. So that and Google had flagged that many years ago even, and finally we've all got it working on Kubernetes at this point.
Right. For folks that are building larger environments, there's a lot of things to take into consideration. There's not just, how do I scale out the environment that runs the containers, but also there's a whole slew of things that you've got to do to sort of do like out-of-band management. Talk a little bit about how you guys, so you build this big environment and then you want to be able to kind of monitor, manage, track, log. What are the other kind of core elements that have to go on when you're building these big environments?
Well, yeah, so the out-of-band management was handled by, we had the OpenStack cloud underneath us, and we were able to leverage OSP Director, which handles out-of-band management and bare metal provisioning of the actual servers. The monitoring, what we did was, so we have our own distributed system analysis tool called pbench that our group has written, and we use that extensively. At the same time, we also use collectd to stream off metrics to Graphite and Grafana system, and the blog includes some graphs, and that's from Grafana. Okay. So that's what the monitoring. That's how we handle the monitoring, and the logging stuff is we haven't had a reason to do centralized logging at this point for the master nodes yet. There's only a handful of them, and hasn't really been an issue for the pod logging. However, we have an Elasticsearch, Fluentd, and Kibana, an EFK stack in OpenShift that we deployed. Okay.
So that's kind of the container element of this, the infrastructure, if you will. And then you go into a decent amount of depth about, loading up the clusters with various application profiles. Talk a little bit about, kind of what type of profiles you're trying to establish, and then, for people that are trying to do some load testing, like what kind of tools are you taking advantage of?
Right. And this is important. I didn't get into too much detail on the blog, but the background and how we came up. So we've developed a tool called the Cluster Loader, and it'll allow you to – we're trying to answer the question of how many pods can you shove into a Kubernetes cluster, and it sort of grew from there to account for all of the type of objects in Kubernetes and etcd that we might want to scale test or load test. Sure. So it grew into a tool that you can configure with a YAML file. And if you look at the blog, the guts of the YAML file are not arbitrary. They're taken from our existing free tier on OpenShift.com, what we give people for free, or what we're considering giving people for free, assuming everything works out. Mm-hmm. That's what we would basically we would set limits for each tenant within OpenShift to those settings. So that's what we're trying to target. We don't know the answer of what it's actually going to be yet. OpenShift 3 is currently out in a limited developer preview mode right now, and we're actively learning about the environment as it is. So that's where the configuration comes from. And I think the beauty about it is that we can extend that very easily to include any type of basically any arbitrary object and any complex set of applications. As long as it can be expressed in a template, we can deploy it with this single tool.
Right. Well, and I think there's a couple of other aspects of that are really important and valuable for people. One is as we move to these environments where companies are offering not only software that people can buy, consume, modify, but these sort of online environments, there's a direct feedback loop that people can get about what people are doing in the environments and so forth. So you guys are using direct developer preview type of insight to help us build the product better, as I understand it. But the other thing that's cool that you guys do is you're putting all these tools online. I mean, they're available in GitHub. They're available as open source. So people don't necessarily always have to just take your word for it or take your methodology for it. They can then just use that as a starting point to then baseline for their environments as well. Is that?
Yeah, I would hope so, and that's one of the whole reasons we put it upstream and into GitHub was that we wanted to maybe not necessarily build a terribly large community around it, but at least be able to share those benchmarks or those utilities with our customers. For example, during the POC phase, we might have some pre-sales folks or solution architects on site with a customer, and they want to size their environment, and why not just hand over the precise tests that we run?
Yeah, no, absolutely, and. In the real world, people may not have access to, 1,000 nodes. They may not care about 1,000 nodes, but they do like having some methodology and some structure around, how do I test some of this stuff? Because there's going to be lots of companies who their IT organizations are kind of getting pushed toward these more cloud native types of environments. And they may be getting pushed faster than they really wanted to. And any help you can provide to people is always very, very helpful. Tell us, you guys, like you said, you had about 6 weeks to work on this. For anybody, looking at the task of having to stand up a bunch of nodes and get them all running, what were some of the things that you guys were able to do to shortcut certain processes, whether it was, automation tools, there was existing things out in the community that you could reuse? Like, how did you make that 6 weeks, possible?
Yeah, I would say that next time, we'll do better, but we did learn a couple of things this time through. I think there's two main issues, and one it actually didn't make the blog. I don't know why, but it's not in there. It's something called the image provisioner, which is a set of Ansible scripts that it is upstream in our repository, which is github.com/OpenShift/SVT. And if you go in there, there's an image provisioner. And what it does is it'll take a QCOW-based rel image and bake everything possible into that image in terms of the OpenShift packages, the container images. It sets up SSH keys or whatever else to basically generate a gold image in an automated fashion. And because we were discovering issues and iterating heavily, creation of that gold image or automation of the creation of a gold image was a huge, huge issue that we had to, basically when we realized how many times we were going to have to iterate, the first thing to do was to write all of that Ansible. And so that's after we had gotten over that hump, it was a lot easier to become more productive. Right.
And I think you highlight throughout the blog and kind of your learnings that, the things that you had available through Ansible, through one of these automation tools was sort of, you couldn't have survived without it. I mean, having that thing there to do those basic tasks that somebody else had, kind of already put together has to be the starting point for any of these environments.
Yeah, totally. I mean, there was simple things like I think we had to flash the NIC firmware across, however many 300 systems. We had to we had to do some LVM juggling based on how Intel gave the gear to us. We had to do a lot of kind of hideous stuff at scale just before we could even do OpenStack and Ansible or a tool like it, basically.
Yeah, Chef Puppet, sure.
Yep.
Yeah, no, it's that low level plumbing that nobody wants to think about. I mean, nobody talks about it in a meetup or a DevOps day or container summit, but it has to be done, types of stuff. What about just general lessons? So, your team is doing testing. It's not always at the scale of 1,000 nodes, but you're doing testing. You're looking at how to optimize things. Like what sort of lessons, can you pass along to anybody who's going, hey, I'm trying to get smarter at this stuff. Like, how are you guys learning, Docker and Kubernetes that's moving so fast? How are you, what are the sort of latest and greatest in testing tools? What other sort of lessons can you help people with?
Yeah, well, we try and push all of our stuff upstream so that, anytime we learn something, we automate it and it becomes part of our repository. To be quite honest with you, we leverage the communities as much as possible. The Slack communities, I know we participate there, and all of the SIGs. I would say that the Kubernetes SIGs are probably the most underutilized portion of the Kubernetes community. I mean, there's maybe a dozen people on each one of so the SIGs, there's probably a dozen of them or maybe less at this point, but there's special interest groups within the Kubernetes community, and we participate in maybe 4 or 5 of them at this point. Those one, if I actually mentioned this to, at LinuxCon, is that if you're a customer and if you want to get into Kubernetes in terms of learning it or debating features and the merit of those sorts of things, those SIGs are I think an underused resource.
Yeah, and SIGs being sort of special interest groups within the broader community.
Yes.
Yeah.
Yep.
Excellent. So, obviously, what ends up happening with these things all the time is you guys put in a ton of work. It's all behind the scenes. The blog comes out, the announcements come out, and then everybody goes, well, what's next? You're recovering, and then everybody wants to know what's next. Like, what do you do with these types of learnings? What do you potentially consider as a next step? And maybe the better follow-up question is, because this is an open cluster environment, like, what do you expect to see people doing? I mean, is this something that they expect only vendors are going to work with, or, is this open to, kind of end customers or other, groups to work on the cluster environment?
It seemed like the rule, I don't know exactly, but it seemed like the rules where anyone who wants to push forward open source is welcome to have a piece of the cluster, or at least apply for access. And
yeah,
that's done through their GitHub by sending a PR. We'll send another one for our part 2 of all of this. Some of the things we're going to do is we're going to work directly on bare metal, hopefully get access to more than 300 nodes. We want to do some more application level testing and data plane testing. A lot of what we did this time was it was fairly realistic control plane. I always try and get as close to the application level testing as possible. So we'll be deploying thousands and thousands of web applications with databases, and the one other piece is persistent storage. So next time we'll wire up, we'll configure a Ceph or a Gluster cluster, and the persistent volume dynamic provisioning stuff we'll also set up and test.
Yeah, no, that's very cool. I know, whether it's Kubernetes or Mesos or Docker, I mean, every sort of persistent storage and persistent applications is top of mind for everybody trying to figure out how do I move more than just a cloud native 12-factor application into this. How do I potentially move other parts of my portfolio? So that's very, very cool. You guys will be doing that. Kind of to wrap this up, where's a good place for people to, follow what you guys are doing, whether it's a GitHub repository or places that, you're going to be out, in the community talking about things, or other places to get in touch?
Yeah, I mentioned our GitHub earlier. It's just github.com/OpenShift/SVT. We also have a Trello board, so you can see, everything we're working on. It's our only source of truth, so it's exactly what we're working on. Nothing hidden there. And as far as where we're going to be, definitely KubeCon in November. Maybe we'll even have part 2 ready by then. I can't promise anything, but that maybe is a good goal. And any other industry events, we'll probably have representation there.
Cool. Very, very cool. Well, Jeremy, thank you so much for the time today. And, big kudos to Intel for, basically funding the cluster. They've been not only kind of a great fan of this show for a long time, but they're doing a lot of stuff like this. They're doing it, with the CNCF Foundation for Kubernetes. They're doing it with OpenStack. They announced some stuff, 6-7 months ago. So it's cool that the people that, can help from a facilities and a resource perspective, and then can help these bigger communities, grow and learn from. So very, very cool. Well, listen, Jeremy, thank you for being on the show today. And for Aaron, who'll be back next week. Folks, thanks for listening, and we'll talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.